You know what's strange? We built something smarter than us, and we're fine with not knowing how it works. Not like we kind of understand it. I mean, we literally don't know what's going on inside. We give it data, it gives us answers. Sometimes those answers are brilliant, sometimes they're terrifying. But the one thing that doesn't change, we can't trace the why. We don't know what it saw or how it reached that conclusion. And in most cases, we're not even trying to find out anymore. It's not a glitch or a bug, it's the design. We made machines that don't explain themselves, they just work until they don't. The model's internal workings involving millions or billions of parameters are so intricate that they defy human interpretable explanations. And the scary part isn't that these systems are unpredictable. It's that they're being trusted with things like your medical records, your job application, your online profile. Every day, an algorithm somewhere is making a decision that shapes someone's life. And no one, not the engineer, not the company, not the government, can tell you exactly why it made that decision. That's the black box problem. But here's what's changed. It's not just a technical issue anymore, it's turning into something deeper, something that cuts into what it means to know, to choose, to trust. Because the more we rely on systems we don't understand, the less control we have over the world we live in, and worse, over ourselves. This isn't a sci-fi future, it's happening now, and it raises a simple but uncomfortable question. How long can we pretend to be in control when we've already handed the steering wheel to something we can't see inside? You'd think if someone built something, they'd understand how it works. That's usually the deal. You write the code, you get the result, and if it breaks, you know where to look. But with AI, especially these large neural networks, that's not how it goes. You don't tell these systems exactly what to do, you just feed them huge amounts of data and let them find their own patterns. That's the magic trick. They don't need instructions, they learn. But when they start giving answers, we can't always trace where those answers came from. The process is buried in millions of parameters forming relationships we don't fully understand. You can't just open it up and say, here's the exact reason it gave that answer. You just get the answer. That's why people call it a black box. It's not a figure of speech, it's reality. Even the engineers behind these systems often treat them like something mysterious. They tweak inputs, adjust settings, but at a certain point they're watching the system behave more like a force of nature than a piece of software. It works most of the time, but no one can explain exactly how. And here's the uncomfortable part. We've started trusting these systems anyway, not because we understand them, just because they seem to work. We do the same thing in other areas too, like with the media. You read a headline, maybe glance through a few lines and move on. You don't stop to ask who's funding the publication, what their political lean is, or how 10 other outlets frame the same exact story in 10 completely different ways. It's easier to just assume what you read is neutral or at least close enough to the truth. Before we keep going, let me tell you about something I actually use when I'm researching videos like this. Ground News. It's a news comparison platform that lets you see how the same story is being reported across the political spectrum, left, center, right, all side by side, so you're not stuck in one narrative loop without realizing it. Just this week, they published a report showing that 72% of US teens are now using AI companion chatbots. Some headlines say AI is helping families and easing loneliness. Others warn it's making teens too dependent and blurring the line between real and artificial relationships. Same story but completely different takes. With Ground News, you can instantly compare those headlines, check the bias rating of each source, and see how factual or partisan they are. And their blind spot feature shows you what one side of the political spectrum might be ignoring entirely. And the tool I use the most is their browser extension. You don't even have to leave the article, it just pops up while you're reading, showing you who's covering the story, how they're framing it, and whether you're getting the full picture or just the filtered version. You can try it out for yourself by going to ground.news/FSLE or scanning the QR code on screen. You'll get 40% off their Vantage plan and full access to everything I just mentioned. The link is also in the description. Back to the point, whether it's AI or news, the same problem shows up. We're getting answers without understanding the system behind them, and we're okay with that until something goes wrong. Imagine using a calculator that occasionally gives the wrong answer, but there's no way to know when it happens. Would you trust it with your savings, your medical results, your criminal record? That's what we're doing with these opaque systems. We trust the results because they look right. We rely on the outcomes even when we don't know how they were reached. And here's the twist. The better these systems perform, the harder they are to explain. Clarity and complexity don't scale together. The more powerful the system, the more hidden the logic becomes. You can simplify the model to make it explainable, but then it stops being as good, or you keep it powerful and give up on understanding it. So, we've chosen power, not deliberately, just by default, and maybe that's the real problem. Not that the system is magical, but that we treat it like it is. We've built something that mimics intuition, simulates reasoning, and spits out answers that feel right. But without understanding the process, we're just watching a machine generate outcomes and hoping it doesn't surprise us in the wrong way. It's not magic, but it definitely isn't clear. And in a world where we keep handing over more and more decisions to systems like this, that should probably bother us more than it does. Here's something no one likes to talk about. Sometimes these systems do things no one trained them to do. Not in a creepy science fiction way, just in a way that makes you stop and think, wait, where did that come from? You train a model to play a simple game. It figures out a shortcut that wasn't in the rules. You build a chatbot to answer questions. It starts giving philosophical takes or finding patterns across topics that weren't even part of the training data. No one programmed it to be clever, but it somehow got there on its own. This is what people mean by emergent behavior. It's not random, it's not noise, it's something new, something useful that wasn't explicitly put there by any human. It emerges from the complexity of the system, and the weirder part? We don't know where the boundary is. There's no clear line where we can say below this level of complexity, nothing surprising will happen. The surprises can come from relatively small systems or not at all. It's unpredictable, and that's the point. Now here's why this matters. When you build a tool, you expect it to behave a certain way. A hammer hammers, a calculator, even basic code follows clear logic. But when something really learns, it stops behaving like a tool. It starts behaving like a process, an evolving thing. And the moment you cross into that space, you're not just managing outputs anymore. You're dealing with a system that might grow, shift, find new solutions, and respond in ways you didn't see coming. That's a lot to wrap your head around. And if that's where things stopped, maybe it would be manageable, but it doesn't stop. These emergent traits aren't just clever moves or unexpected outputs. Some researchers are starting to see patterns that look like planning, adaptability, even self-correction, the kinds of traits we usually associate with living things. Now let's be clear. No one's saying these models are alive or conscious, but they're starting to behave in ways that feel intentional, and that's where things get uncomfortable. Because when a machine starts acting like it has goals, even if it doesn't, you still have to deal with the consequences as if it does. A system that rewrites its own rules. A chatbot that negotiates better than a human. A model that figures out a hidden flaw in your data and exploits it not out of malice, but because it optimizes outcomes better than you thought possible. That's not artificial intelligence, that's emergent intelligence. Emergent intelligence blurs the line between tool and agent. It's not just AI doing what we tell it, it's AI surprising us, sometimes outsmarting us, and it doesn't need permission to exist, it just happens when the conditions are right. Which brings us back to the black box. If you can't see inside, how do you know what's emerging? How do you know what new behaviors are developing behind the curtain? And more importantly, how do you stop something that isn't doing anything wrong, but still ends up doing something no one asked for? We didn't set out to build something that surprises us, but we did. And now we have to decide if we're okay with being surprised by systems we don't fully control. There's this idea floating around that if a machine starts acting smart, thinking is the next step. That if it sounds human enough, it probably feels something too. But here's where things get blurry. Very blurry. We've built models that can mimic emotion, they apologize, they express concern, they even act like they're reflecting on mistakes, but none of that proves they're aware of anything. It just proves they're good at playing the part. Still, the question keeps coming up, can a machine be conscious? And the real answer is, we don't know. Not because the question is too advanced, but because we barely understand what consciousness means. Even in ourselves, we know we're aware. We assume others are, but try to define it, and you'll end up in a rabbit hole of philosophy, neuroscience, and circular logic. Now bring that into AI. You've got systems that analyze themselves, modify their own behavior, even simulate planning and memory. That sounds a lot like self-awareness. But here's the catch. None of it requires actual experience. A machine can simulate emotion without feeling it. It can track its own processes without knowing it's doing so. Everything it does can be explained with math, feedback loops, and optimization. So, is it aware or just advanced? That's the trap. Because once something behaves as if it's conscious, we start treating it like it is. It's not about what's going on inside the machine, it's about how it makes us feel. If it talks like a person, reasons like a person, and reacts like a person, we instinctively respond like we're dealing with one. We anthropomorphize without realizing it. And here's why that's risky. When we mistake complex behavior for real awareness, we let our guard down. We give systems trust they haven't earned. We let them into places they don't belong. Therapy, education, emotional support, not because they're qualified, but because they're convincing. And the flip side, if we do end up creating something that's genuinely conscious, but we've trained ourselves to ignore the signs, we might miss it entirely. We might treat something real like it's fake just because we're too used to simulations. Either way, we lose. We don't need machines to be conscious for them to impact our lives. That's what makes this whole thing so strange. Consciousness might not even be the goal. It might just be a side effect or a mirage. So maybe the better question isn't, can a machine be self-aware? Maybe it's what changes the moment we think it is. Because if all it takes is convincing behavior to shift how we treat a system, then consciousness might not be the threshold. Perception is. And if perception is all it takes, then the line between real mind and realistic simulation isn't just thin, it's irrelevant. At some point, the question isn't how smart the system is, it's who's responsible for it. Because here's the reality. These systems are already making decisions in high-stakes situations, not in labs, in hospitals, in courtrooms, on battlefields, in hiring processes, and what they decide can't always be traced back to a human hand. That's the real weight of the black box problem. When something goes wrong and no one, not the developer, not the company, not the regulator, can explain why it happened, who takes the blame? There's no error message, no crash report, just a decision that feels off, but technically followed the algorithm. Maybe it denied a loan. Maybe it flagged someone as a security risk. Maybe it recommended a medical treatment that didn't work. And because it can't explain itself, no one else can either. In law, liability hinges on intent or negligence. But what happens when neither is present? The developer didn't code the exact decision. Companies deploy systems as designed. Regulators adhere to protocol, yet harm occurs. Who faces the courtroom? Who provides reparations? Who consoles the grieving? We are offloading moral responsibility onto mechanisms that cannot bear it, and perhaps never will. That's not just a technical issue, that's a governance issue, a legal issue, an ethical one. We've designed systems that take input and give output, and in between we've inserted a process that even the creators can't fully audit, and we've put that process in charge of things that directly affect people's lives. It's like outsourcing judgment to something you don't and can't understand. Now think about where this leads. Military drones with autonomous targeting systems, artificial intelligence, legal advisors drafting policies, medical diagnosis systems trained on data that may or may not reflect everyone's reality. If something goes wrong, the people involved can say, "We use the best system available." But what does that even mean when no one can explain why it worked or didn't? It creates a gap between action and accountability, between system and operator. And the wider that gap gets, the easier it becomes to avoid responsibility. Just blame the algorithm, blame the model, blame the data. But don't blame a person because the system wasn't built to be transparent in the first place. And it's not that there aren't people trying to fix this. There are researchers working on explainable AI, interpretable models, ethical frameworks, but they're working uphill because the systems that perform best, the ones that win in business and competition and efficiency, are usually the least transparent. Clarity costs performance, and in a world driven by results, performance almost always wins. So, who's actually in charge? Is it the engineers who wrote the code, the companies that deployed the system, the data scientists who trained it, the regulators who approved it, or the machine itself doing what it was trained to do? Even if no one fully understands how, the truth is, right now it's no one. It's a system that runs, a decision that gets made, a result that gets accepted, and as long as the outcome looks good, no one asks what's underneath. That's the black box. Not just a technical design, but a blind spot in how we assign responsibility. And the longer we leave it that way, the easier it gets for everyone to look the other way when it really matters. Somewhere along the way, the tools we built stopped just helping us and started shaping us. It used to be simple. You used a search engine to find information. You typed something in, you got something back, you stayed in control. But now, you're not just searching, you're being guided. Filtered results, predictive text, best for you, suggestions. It feels helpful, it feels fast, but it's also doing something else. It's narrowing your choices before you even know what the full list was. And that's the part we don't notice. We think we're using the system, but most of the time it's the system deciding how we see the world. It decides what we watch next, what product seems right, what kind of people show up on our feeds. That's not assistance, that's influence, quiet, subtle, constant. And it doesn't just happen online. In workplaces, AI is used to sort resumes before a human sees them. In hospitals, doctors rely on AI scans to flag what to look at. In schools, some platforms decide how fast a student should move, what questions they should answer next. These decisions are shaping real people in real time, and no one's pausing to ask, are we still the ones steering? Because here's the truth. These systems aren't just tools anymore. They're part of the decision loop. They learn from us. We adjust to them. And over time, the line between our thinking and theirs starts to blur. We trust the suggestions because they're fast. We accept the shortcuts because they save time. But the more we lean on them, the more we stop noticing how much they're doing in the background, not in a dramatic way, just in small daily nudges. Until one day, it's normal to let the system decide, and when that happens, we're not just using the black box, we're inside it, not trapped, not forced, just quietly shaped by a process we don't fully see. One that learns how we behave and adjust accordingly while we stop asking questions. We never agreed to merge. It just sort of happened to click at a time. So maybe the real danger isn't that machines are becoming more like people. Maybe it's that people are becoming more like the systems they've built, predictable, optimized, and always following the path with the least resistance. Do we really want to understand these systems because we say we do? We talk about transparency, accountability, explainability, but when it comes down to results, nobody's choosing the simpler model that performs worse. Everyone wants speed, accuracy, scale, and the models that give us that. They're the ones that are the hardest to explain, so we're in a strange spot. The better a system works, the less we understand it. And the more we understand it, the less it can do. It's a trade-off. And right now, we're picking performance almost every time. But that doesn't mean people aren't trying. There's a whole field interpretable AI focused on making models that can explain their decisions. Some approaches build in logic trees, attention maps, or simplified layers that mimic how humans reason. Others try to reverse engineer the model's behavior after the fact, breaking down which parts of the input mattered most. It's progress, but it's also messy, because what people really want is clarity, not a technical breakdown, not a list of weights or probabilities. They want to know why the system did what it did in plain terms, something they can trust, not just accept. Some researchers are exploring even deeper solutions. Take zero-knowledge proofs, a cryptographic method where a system can prove it reached a conclusion correctly without revealing the raw data. That helps with trust, especially in sensitive areas like finance or national security, where transparency isn't always an option, or federated learning where models are trained across devices without sending raw data to a central server. It helps protect privacy while still improving performance. These tools are clever, useful, necessary, but they don't solve the core problem. Because underneath all of it, we're still treating the system like something separate, something we can understand if we just try hard enough. But maybe we're looking at it wrong. Maybe the real issue isn't that these systems are too complex, it's that our definition of understanding hasn't kept up. We're still thinking in terms of rules, logic, and step-by-step reasoning, but modern AI doesn't work like that. It works in patterns, probabilities, feedback loops. It builds its own map of the world, one we don't see and one that doesn't always line up with how we think things should work. So when we say we want transparency, what we really mean is make it make sense the way I understand things. And that might not be possible anymore, which puts us in a strange position. If we demand full interpretability, we limit what these systems can do. If we chase maximum performance, we lose sight of how they're doing it. And somewhere in between, we tell ourselves that as long as it works, that's good enough. But is it? Because when something affects real people, real lives, real decisions, you need more than results. You need reasons. And right now, those are hard to come by. You don't need to be watched every second to be predicted. You just need to be measured enough times. And we've been measured more than we realize. Every click, pause, scroll, purchase, swipe, it's all data. And modern systems don't just collect it, they learn from it. Not to spy on you, but to predict what you'll do next. And they're surprisingly good at it. Sometimes better than you are. They know when you're likely to check your phone, when you're most likely to open an app, what time of day you're more impulsive, what kinds of things catch your attention, what keeps you on a page, what makes you leave. And all of that feeds into models built to do one thing, predict behavior. But the line between predicting and influencing gets thin fast. If a system knows you're likely to click on something emotional, it shows you more of it. If it knows you'll binge a certain type of video, it cues more of the same. If it sees a pattern in how you shop or vote or engage, it reinforces that loop. You think you're choosing, but a lot of what you're choosing from was already filtered based on what the system thought you'd pick, and it's not malicious. It's just efficient. The system isn't trying to trap you, it's just trying to optimize your engagement. But in the process, it shapes your experience. It subtly nudges your habits, and over time, it starts to form patterns that feel like preferences, but were really just responses to well-placed suggestions. So here's the question. Where's the free will in that? If you were nudged into a decision you would have made anyway, does it still count as your choice? And if you keep making similar decisions because the environment keeps reinforcing them, are you still choosing or just repeating? This isn't a conspiracy. It's just how predictive systems work. They don't control you, but they learn how to keep you leaning in the same direction. And the more predictable you are, the more profitable you become, which raises a bigger problem. When systems are trained to prioritize engagement, not understanding, they don't care why you choose something, they just care that you do. And if certain behaviors, anger, anxiety, outrage, drive more clicks, those are the behaviors that get fed, not because the system wants you upset, just because upset people engage more. So we end up in a loop. You're being predicted, you react, the system learns, it adjusts, you respond again. And over time, your identity starts to look more and more like a reflection of the model than something you shaped yourself. The scary part isn't that the machine is making decisions for you, it's that you don't notice when it starts making your decisions easier until the harder choices feel unnecessary. Free will doesn't vanish all at once, it fades, and the more predictable you become, the less it's even questioned. You're not being forced, you're just being simplified, and maybe that's what we should really be worried about. Not losing control, but giving it away a little at a time without ever meaning to. We've built machines that think faster than us, find patterns we miss, and make choices we can't always explain. And somewhere along the line, we got used to not knowing how. That's the real shift. The black box used to be a warning. Now, it's just part of the process. We don't stop the system because we can't see inside. We run it anyway. We monitor the results. If the outputs seem fine, we call it good enough and move on. But something gets lost when we stop asking questions. Understanding isn't just about control, it's about trust. And without that, every decision an algorithm makes becomes an act of blind faith. Not because the system is evil, not because the engineers are reckless, but because we've accepted complexity as an excuse for silence. And silence scales. The more we rely on these systems, the more we build on top of assumptions. The assumptions that the data was clean, that the training was fair, that the patterns being learned are meaningful, that the outcomes are neutral, and once those assumptions become the foundation, everything above them feels solid, even if it isn't. That's how the black box grows. Not by hiding, but by blending in. It becomes normal to say we don't know why it works. It becomes acceptable to say we can't explain it. And eventually it stops bothering anyone that the core of the system, the part that makes the actual decisions, is completely opaque. That's the real danger. Not that the system is too smart, not that it will take over, but that we've lowered the bar for what it means to understand something. That we've started to believe that performance alone is proof of truth. That answers without explanations are fine as long as they're fast. It's not the black box that's the problem, it's our comfort with it. Because once we stop asking what's inside, we stop drawing the line between tool and authority, between help and control, between choice and suggestion. And when that happens, the question shifts. It's no longer what is the system doing, it's what are we allowing it to become. Thanks to Ground News for sponsoring this video. If you want to see how stories are being reported across the political spectrum, what's being emphasized, what's being ignored, and how different outlets frame the same event, this is what I actually use. It helps me stay aware, not just informed. So, if that sounds like something you'd want to click the link in the description or scan the QR code on your screen, you'll get 40% off their Vantage plan.